Okay, so this is the 7.3 lesson on the Pythagorean theorem. In your notebook, you should be writing down 7.3 lesson, title it Pythagorean theorem, and then let's get started on the key ideas. So the sides of a right triangle, again, make sure that you are noting that this has to be a right triangle. In order for Pythagorean's theorem to work, it has to be a right triangle. So the special names that they have for a right triangle, there are two legs, and then there is a hypotenuse. The legs are the ones, as you can see in this picture, that form right here and right here to create that 90-degree angle. It does not matter which one you label as A and which one you label as B. But the hypotenuse is the one that is across from the right angle. So if you look like this, it is directly across. The other way that you can remember the hypotenuse is that it is the longest side. So I'm going to add that here. And you should add that to your notes. Okay, so those of you that were in class today being Monday when I'm recording this, we proved Pythagorean's theorem that a squared plus b squared equals c squared. And again, for those of you that weren't here, a quick rundown was that if you have a square, it's a terrible square, but if you have a square off of side 1 and 2, legs A and B, it would equal the square on the hypotenuse. So if this side was 2 and this side was 2, the area is 4, the area is 4, this total area would be 8, which would mean the hypotenuse side would be the square root of 8. Okay, so that is our key idea. We know that this is Pythagorean's theorem, and again, we know the proof behind that is that the squares equal the hypotenuse square. So let's move on to example 1. Sorry for the quality of this picture. I know it's not the best, but we can read it. Okay, so in this one, they're asking us for the length of the hypotenuse. This is example 1. We can see clearly that it is the side that's across from the right angle, and it definitely looks like it's the longest side. So remember Pythagorean's theorem, a squared plus b squared equals c squared, and your two legs are the ones that are listed in red and blue. And again, it does not matter which one you label as A and which one you label as B, because we know addition is commutative. So it wouldn't matter if we said 5 squared plus 12 squared, or if we said 12 squared plus 5 squared. Does not matter which one is A and which one is B, because 12 squared plus 5 squared is still going to equal the same thing. So we do 5 squared. 5 times 5 is 25. And we do 12 squared, and 12 times 12 is 144. And if you don't know those off the top of your head yet, you will probably start to remember those, because these are going to be the numbers that you use quite often. Okay, so then keep simplifying. 125 plus 144 is going to give us 169, and that's what the square would be. So again, if we were drawing a square off of the hypotenuse, the area would be 169, but they want the length of the hypotenuse side. So to undo the square, we do the inverse operation, which is the square root. So that cancels out the c squared, and it just leaves c. And then remember the square root of 69, in case you don't know that one off the top of your head, use your benchmarks. So probably the closest benchmark would be square root of 100, which we know is 10. I'll write that down. And then if we just keep going up from there, 11 would be 121. We know 12 is 144. And 13 times 13 is 169. So we found the side length is 13, and then don't forget to label with meters. So that is it for example 1. And now you should do the on your owns 1 and 2. So pause this video and do on your own 1 and 2. Okay, so now we're going to look at example 2, and remember you can check on your own answers after we're done with this lesson. So the difference between this example and the previous one, as I'm sure you can probably already tell, if you turn your book sideways, notice that the right angle is here. And so you're not missing the hypotenuse this time. This is the hypotenuse. You are actually missing a leg. So they're actually labeling this A. They're telling you you don't know what A squared is, but remember Pythagorean's theorem, A squared plus B squared equals C squared. So we're going to leave the A. We're going to plug in the leg, which is 2 and 1. Sorry, I can't do a dot. 2 and 1/10 squared. And we know that that equals 2 and 9/10 squared. So we're going to have to evaluate. I would probably treat this as 21 and 29. And then you can put the decimal point back in. So I'm going to do that off to the side here. 21 times 21, 2 times 2 is 4. So that's 441. And then go back and put your decimal points back in. So there's 2 numbers after the decimal point, which means I go back twice. So 2 and 1/10 squared is 4 and 41/100. I don't know what A squared is, so I'm just going to bring that down. And now I need to do 2 and 9/10. So again, I'm going to treat that as 29 and 29. Okay, 81, carry the 8. 9 times 2 is 18. 18 plus 8 is 26. Okay, that's a 6. 9 times 2, 18. 4, carry the 1, that's 5. So add it all up. 5, 6, 7, 8. That gives me, putting back the decimal points, 2 numbers after the decimal place, so go back twice. That's 8 and 41/100, which actually I see is going to work out nicely. Okay, so we are using inverse operations to solve for A squared, which means we're going to subtract 4 and 41/100 from both sides. And we're going to be left with A squared equals, that's gone, so just 4. You don't even need these extra zeros, I was just showing you. Okay, so that would be the square off of the leg, but we want just the side length. So once again, to undo the square, you're going to take the square root, and you're going to get 2 centimeters. And on a problem like this where actually I guess you could do this for any of them, but just make sure that when you find your missing piece that it makes sense. So if I were to say that this is 2 centimeters over here, it has to be smaller than the hypotenuse. So this makes sense, that 2 and 1/10 and 2 are both smaller than 2 and 9/10, because remember the hypotenuse has to be the longest side. Okay, so that is example 2. We're going to do our last example. Example 3. So here's our real world application problem. All right, so you're playing capture the flag. You're 50 yards north and 20 yards east of your team's base. The other team's base is 80 yards north and 60 yards east of your base. How far are you from your other team's base? So this is kind of like what we were talking about in class on Monday about helicopter distances is the straight line path, and then if you're staying on the grid, you're driving. So we are here at 2050, and the other base is here at 6080. So the only reason that that's applicable is that's helping you find the lengths of these 2 legs, even though on this grid you could probably count it anyways, that this is 30 because the scale is going up by tens. So really that's 10, 20, 30. Sorry, that's a little bit off. Okay, so we want to know how far we are from the other team's base. Basically, we want to know what this is right here. We know legs, but we don't know hypotenuse. So we are simply going to use Pythagorean's theorem, in case you haven't remembered yet. A squared plus b squared equals c squared. Plug in the two legs, and again, it doesn't matter which one you plug in for A and which one you plug in for B, but you're solving for C. So we're going to square these. Again, just number sense tells me I'm doing 3 squared, but don't forget that you're doing 30 times 30, so you need to add 2 zeros onto it. So it's going to be 900. And then 40 squared is going to be 16, because 4 squared, 4 times 4 is 16. But then to 2 zeros, since it's 40 times 40. And that equals c squared. Okay, combine your constants. It's going to give you 2,500 equals c squared. And then to solve for c, take the square root, so it will cancel out. And the square root of 25 is 5, but then we know that because there's 2 zeros, it's got to be 50, because when you do 50 times 50, you'll have those 2 extra zeros. And a label on this, because they told us it was yards, we're going to label that 50 yards. So we are 50 yards from the other team's base. Okay, at this point, there are 3 more on your owns in your textbook that you should work out. And you are going to check your answers on the Google form. Don't forget to correct them. So take your red pen. Once you're done submitting them, you'll get your feedback instantly, the answers instantly, and then you're going to mark wrong and correct what you did not do correctly. Please don't just mark it wrong and move on, but actually try to figure out why you got it wrong. And then you're going to go to the assignment and take a picture of your notes, including all of your try it yourself on your own questions, and post that to the assignment and turn it in. Okay? If you have questions, please put it in the comments of this post, and hopefully between the 31 of you and 1 of me, we will get your question answered. Thanks.